For the community that is following the event on YouTube. I'm going to talk about network security using MikroTik devices. My name is Wilmer Almazan. I'm a computer system engineer, a software developer. I'm a MikroTik certified trainer. I have several MikroTik certifications and also from other organisms. I work at Ynet. We offer training in Canada and Latin America. We have offered trainings in different cities in Canada, also Mexico, Central and South America. And today, I want to share something about network security. According to different studies, 5 minutes is the average time that takes for a device to be attacked. We plug it in internet. So we have to be aware about that. And sometimes we used to start working, just we focus on routing and different things about security, about the network, but we forget everything about security because we put this in the last step of the process. But we think that security should come from the beginning. We have to plan everything, and we have to have all the policies defined. Unfortunately, we have a good friend that is the RouterOS that has a very powerful firewall. Obviously, we are in an enterprise level. We will need to have different systems working, but one of the systems that can help in the layer 3 and 4 and now some applications in layer 7 is RouterOS. But first of all, we need to be aware about what are we talking when we say network security. So when we talk about network security, basically we are talking about three things. We have three objectives. One is the confidentiality. Second one, integrity. And finally, availability. This is known as the triad of security, CIA. When we say confidentiality, we are we want that the content or the data is gotten by the person that we send this data, is not revealed to anyone else. When we say integrity, we are talking about the content that is intact, it has not been modified. And the last one, availability. The resources should be available for the user whenever they need it. So what can we do to get these three elements? Okay, first, we need to know them. We need to know all the threats, the possible attacks that we can find in our network daily activities. So basically, we have two types of attack or threats. One of those are the active, the other one the passive. When we say active, we are talking about interruption, modification, fabrication, and with passive, it's just interception. So the first one, interruption, basically a message is sent from a source. I'm sending any content to a destination, and probably in that path, someone is taking this information, is blocking this communication. So this is known as interruption. The second one is interception. In this case, this is the passive one. So I send a message to a destination, but someone that path is taking these messages is not doing anything about the content, but is listening. So that is why this is a passive attack. The third one is about modification. So I send the message, someone takes the message, going to alter the content, just changing some bits, they can do this, and then this message is sent to the destination. So in this case, this is called modification. And the last one, that is fabrication. Basically, someone not allowed or unauthorized in the network is creating messages and sending to the destination. So those are the types of threats. When we say threats, we are talking about a weakness that is in the network. Probably is not being exploited yet, but it can cause an incident. So you have to be aware and take some actions to prevent that. So there are different types of threats that we can find in all the layers in the OSI model. As you can see, if we start from the physical up to the application layer, we have different threats that we have to be aware of them. But we will focus in this presentation about threats in the layer 3, that is the network layer, and the layer 4, the transport layer, using MikroTik RouterOS. So after this layer, we can go with system information and event management and other type of system to manage all the information that we can get from the lower layers. But in this case, we are going to focus in on specific devices in layer 3 and 4. The first threat is the DDoS. This is a distributed denial of service. This is an attack that it can be created by a single machine or maybe several hundreds or thousands of machines in different places of the world. We call DOS when it's just a machine creating the attack, or DDoS when there are several. Okay, how can we know if we are being target of a distributed denial of service attack? There are different symptoms that we can analyze in the network. For example, are there too many connections with the send state? We can find this if we go to the IP firewall connection print. This is if we go with the command line interface, the CLI, or we can go with the menu, the Winbox. We can see a table with all the connections, so we can have a real information about the connections, so we can determine if there are too many connections. If we see a lot of connections there, that means that probably we are being victim of a DDoS attack. A second symptom, for example, we can see a lot of packets going through a particular interface. So we can go with the interface monitor traffic, and we select the interface. Also is in the CLI, but easily we can go to interfaces and double click over the interface that we want to check. On statistics, we can find the number of packets that are going through that interface in a particular time. In that case, we can know. It's important for all the network administrators to create a baseline. So the first step when we are starting a network, we have to create a baseline of the traffic and have patterns about the behavior of the traffic during different times. So this, if we compare this number against this baseline, we can know if something bad is happening. The third thing that we can see is the CPU usage. So for example, if we get a 100% of usage, that means that something bad is happening. Because if in normal times we are by 10, 20%, and suddenly we get 100%, something is happening. So we have to go to system resources monitoring. We can check how is the CPU usage. Also in the profile tool, in tools profile, we can see the use of the CPU in different categories that RouterOS is showing there. Also, we can go with the tool torch. In this case, we can analyze the connections. We can go with, for example, to see all the connections from a particular interface, from a particular source IP address to a particular destination address, from a specific protocol. So it's a very harmful tool to check all the connections that we are getting, and we can see even, for example, a particular connection from a specific IP address, how the transmission rate, the reception rate, so we can analyze all this information. Now, the DDoS attacks are one of the most powerful attacks because we don't have control about the machines that are creating this attack. So we can just mitigate because we cannot take control over the boots that are in the bootnet of the attacker. So we can take some actions to mitigate the effect. One of those is to limit the number of connections. So for example, this is a constant, an integer. Here we can go to the filter firewall and just add a chain protecting the router in this case. For example, the protocol TCP, we can set a number according to the baseline that we have created for a particular IP address. This 32 means the netmax. So in this case, we are telling that this is a unicast address. And we can add, for example, this address that is creating this traffic, and we can add it to an address list, and then take a particular action with this address. There are many actions that we can take after that. So the first step is to have all these addresses in a list, and then we can go with the actions like drop, reject, or any other action that we want. The TTP Singh attack is a type of DDoS attack. Basically, here the attacker is taking advantage of the three-way handshake that the TCP connection have by default. So basically, they are sending a lot of requests to the server or the router with SYN packets to start the TCP connections. The router replies, but obviously the attacker is never going to send the acknowledgements to the router. So basically, they just want to flow the router and get it in a denial of service state. So for example, in this case, we have the attacker that has, in any way, it has taken control of all these machines. These machines can be in different places in the world, maybe with Trojan horses or any other malicious software. They have been taking control of these machines so they can launch an attack in a particular time to a specific host. So in this case, all these machines are sending traffic, a lot of SYN packets in requests to this device. So this device is not capable of managing all these requests, and the CPU is going to 100%. Basically, there are three general actions that we can take to mitigate. One is rate limiting each new TCP connection. Also, we can modify the timers. If we go to IP firewall connection tracking, there is a settings button there where we can play with the timers of the different states in the TCP connections. And also we can enable the SYN cookies. This is on IP settings. There is an option for TCP cookies that we can just enable. And this automatically is going to run the algorithm about the SYN cookies to mitigate also the SYN attack. This is an example of rules that you can create. This presentation will be available in the Moon website of MikroTik. So you can, after you want to review this command, you can download the presentation. But basically, we can create different rules to limit the connections. Also, this is the menu where we can enable the TTP Singh cookies. As usual, in RouterOS, everything is very simple. So we have just to enable this option, and with this, we are getting a good protection about the TTP Singh attack. Also, there is another structure that in the last years have been added to RouterOS. This is the Roadtable. So instead of specifying rules on filter in firewall, we can do it on the Roadtable. This is also in IP firewall under the tab row. So basically, this structure is analyzed before the connection tracking. So in this case, we can be more effective about the mitigation of the SYN float attack. So for example, here we can add a rule about the flags, the TCP flags for the protocol TCP. Obviously, we need some rules to also allow these the valid connections and just target the one to avoid the attack. So this is just a single rule, but obviously you will have more rules to allow the valid traffic. Another common attack usually in places where hotspots are running is the DHCP starvation. So in this case, the target are the DHCP servers. The objective is to take all the IP addresses, so when a valid client is getting connected to a network, there are not IP address available, so it cannot get connection. So anyone in a hotspot that is public can go and set up a fake DHCP server and then take all the available IP addresses in the pool that we have defined. So one thing that we can use to prevent this is with port security. For example, we have a switch. We can specify and allow, for example, just one MAC address per port, or we can set a list of allowed MAC addresses. So basically, with port security, we can manage this, but this is just available on the CRS3 switches. So we cannot do this in a regular router board, just in the cloud router switches. So for example, here we create a rule to allow just a specific MAC address. And then here is just the bridge creation. And basically we have to say no to the unicast float for unknown addresses. And finally, we need to add the static entry for all the traffic that is going out from the bridge with the same MAC address that we have allowed. So in this case, we can use the port security using the cloud router switch only. Also, we have the DHCP row. In this case, it's a fake DHCP server. We don't have control over this server. So for example, here we have a router. This is a simple wireless topology. So we have a DHCP server, and this is offering IP addresses to all these clients, but someone can get connection to this hotspot because it's public. They don't have any passphrase to get connection. So this server can also send all the IP addressing information to these clients, and then can make any type of attack, like the man on the middle or another type of attacks to take information of this client that we have there. So we have to enable the DHCP snooping. This is available since RouterOS 6.43. Basically, the idea here is to specify in the switches which are the trusted ports. So for example, if we are installing a switch and we are connecting a DHCP server on port 1, for example, that will be a trusted port. So all the rest of the port where the clients are going to be connected, that will be untrusted. So for example, in this case, this rogue DHCP server is getting connection by Ether 3, but because we are specifying this as an untrusted port, all the packages coming for the bootstrap or the DHCP server, DHCP protocol are going to be discarded in this switch or router. The same here, for example, we have the connection from switch 2 to switch 1. This will be the trusted connection, but we have the untrusted because we don't have control about all the clients that are in the right side. So basically, all these packets for offer and discover are being discarded in this switch. To the traditional configuration that we make to create this bridge, basically we have to add the trusted feature on the interface. This is under interface bridge port, so we have to enable this option. And finally, on the master bridge, on the bridge interface, we have to enable DHCP snooping. So this is the configuration, for example, in this switch, and this will be for switch 2. You can see here we have the port 2, port 1. These are being flagged as trusted. And the Ether 3 doesn't have the trusted. That means no trusted, untrusted. So this server won't be allowed to send these offers to our clients. Another type of denial of service attack is the UDP float. In this case, the previous one was the TTP Singh, so they were taking advantage of the three-way handshake. But in this case, with UDP, we don't have that negotiation. So the attacker is just sending a lot of UDP packets to the target. And basically, this also can be amplified. So for example, if it's a DNS attack to a broadcast address, it can be amplified by the bandwidth that they are using. For example, if the attacker is using 10 megabits and we are using a broadcast address of a network /24, that means that we will have 10 times 254 megabits. So it will be a very huge bandwidth, and it will be almost impossible for the device to manage all that information, and it will be in less than 3 seconds in labs that I have done with the CPU in 100% and then rebooting. And obviously, they are getting the objective that is denying the access for the users. The first thing that we can do is disable the DNS forwarder. Sometimes we just install the routers under IP DNS. There is an option, allow remote request. This becomes the router in a DNS server. But if we are not going to use this device as a DNS server, we can just disable this option. And in this case, the router is not going to reply DNS request. Also, we can limit the UDP connections and block, for example, all the UDP traffic coming from the internet. So we can take any of those 3 actions or all the 3 actions. So this is the window that we can find under IP DNS. So here we have the allow remote request. If we click, we enable this option, we are saying, okay, this is a DNS server. But if we are not going to use that device as with that functionality, we can just disable, and we are doing a lot of part of the mitigation process with that. The next step, it can be on the Roadtable that you can see in Firewall. We have the Roadtable. We can specify a list of all the WAN interfaces, and then we can just add a rule and make a drop for all the traffic that is coming to the DNS ports by these interfaces. In that case, we are protecting the device from all the traffic that is coming from internet. Remember that this is just for mitigation. That don't mean that the attacker is going to shut down the bootnet. They are going to continue sending the attack, but we are going to have very good results with this. We can also have this rule on filter rules, but in that case, this process will be after the connection tracking, and the performance will be bad still. So we will have a better result if we use the raw section. So for example, there is the raw pre-routing. We are just specifying the protocol UDP, the port 53, the interface, in this case, the Ether1, that is the internet interface, and then we just specify a section as a drop. Another type of attack is the brute force attack. In this case, the attacker is trying to get access to the device. So basically, if they get access to the router, they can do anything there. So we have to protect. Sometimes a good approach is to establish a VPN and just allow the access to the device under when the traffic is coming from the address that we have specified on the VPN tunnel. Also, we can limit the number of attempts. Also, we can modify the default ports. Remember that under IP services, there are all the available services on the router. We can change that values. Since this won't be a public device, it's just for management, for network administration, we can have customized ports there because they will be with our information, or just the administrator of the device can handle that information. Another, we can limit logging just for a specific IP address or a range. Also in IP services, we can specify an address or range, just and the router will allow connection just from these IPs that we have set there. And obviously, we have to use complex passwords. It's strange that even in this year, according to several studies, about 60% of the password is 1, 2, 3, 4, 5, 6 password. So even in enterprise levels, because we just put the device there and forget about security, thinking that the attacks are for other people, not for us. Okay. One technique that we can use is port knocking. This is a method that will enable access to the router after receiving a sequence of connection attempts to a specific port. We can specify a list of ports. When we want to access the router, we have to try to connect using these ports, and finally, we are going to be allowed. Basically, the logic is that we have to make, for example, here 3 attempts, and finally, if we follow the correct sequence, we are going to get access to this router. For example, here, first we have a rule where we are going with the port 8000 with protocol TCP, so we have to try to make a connection in this port. Then the address, the source address, or the address that we are using to get connection is going to be added to a list, in this case, stage 1. And then we are going to try to get connection to the port 7000. And the router is going to verify if the address is already in stage 1. If these conditions are met, then the IP is added to the stage 2 address list. Then we are going to make a final attempt connecting to the 6000, and also is going to verify. In this case here, it will be stage 2, a mistake here. And then this will be added to an allowed list. And finally, we will get access to the device. And after that, obviously, we have to have the drop for everything, because if we do all this, but we forget to add the drop at the end, we are not doing anything. The firewall is just decorative. So we have to use this rule at the end of all our allowed rules. Also here we can play with the timeout. For example, here we are setting 1 minute. So in the first attempt, the source address is going to be in the lead for 1 minute. So we have 1 minute to make the second attempt. But we can go with a very low number there. For example, 2 seconds, 3 seconds. But in this case, it would be difficult to type for us that numbers faster. So we can use an app, for example. There are a lot of apps for port knocking. So we can have in that app all the list of predefined ports, and we just make the attempts, and we can limit this time with a very low number. Okay, basically, that is about the DOS attacks using MikroTik RouterOS. We have a very powerful tool. I don't know if you have any question about. Okay, you can use this.
I was just basically wondering, what's the difference between using the raw table in IP tables versus the filter table on the bridge?
Okay, the main difference is that the raw table comes before the connection tracking. So, for example, in the MikroTik website, you can find the flow control of the packets going through the device. But the raw table is coming just before the connection tracking. So that makes more efficient to deal with denial of service attacks. But obviously, if the packets haven't gone through the connection tracking, we cannot go with, for example, connection states with a lot of features that comes after the connection tracking. So we have less options to set the requirements in the rule because it's coming before the connection tracking. We cannot filter the packets using any of the connection tracking features in the raw sections. Okay, for example, in my case, I have done different labs that you can find on my YouTube channel. For example, with this specific case, the TTP Singh attack and the UDP, I made a lab using Kali Linux with a gigabit connection with an RB4011. When I send the attack without any protection, it takes like 1 or 2 seconds to get the 100% of the use of CPU. If I made the rules that I showed you in the filter section, I got like 43% of CPU usage. And if you go with the raw section, it's like 10%. So the connection are getting there because we are not stopping the attack. So if we go to the filter rule, we are going to see that the counter of packets is going gigabits in minutes. But the use of CPU is like 10, 12%. Okay.
For the DNS blocking, your rules showed to do UDP port 53. DNS is now on TCP, I believe. You do TCP port 53 as well.
Exactly, that's a good point. Now DNS is using also TCP. There are a lot of websites and services running under TCP. So we have to add a second rule for TCP. That's a good point.
Just thought I'd point out one other thing too. You got distributed DNS on 5353, and you also have SNMP on 161.
Yes, okay.
At 161, you have a much larger magnification effect
Exactly. There are, for example, the ICMP attacks that have a very big amplification effect. We didn't cover that in this presentation today, but also we can make some mitigations of actions with RouterOS. All this information with depth is covered in the network security course from MikroTik, the MTCSE. There are a 2-day training course with very deep information about different threats, attacks, and ways to mitigate. Yes, the presentation, all the presentation in the MOOCs are available on moom.mikrotik.com. So there you can find all the presentation during the last 10 years, I think, and you can find all the files, the videos.
You mentioned that there are available different clients for the port mounting. Can you suggest any for Windows machine? Where it can be like scripting. Let's say I want to do the remove desktop. I want to run the script like knock, 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 remove desktop, right? Is there any company that I can create a simple script for Windows machine?
No, there are, if you Google it, you will find hundreds. All of them works in the same way. Actually, it's a very simple approach. It's just an attempt for connection.
Well, using what? How do you do it?
Yes, you
I like to use ping with different packet sizes.
Yes.
One packet of X size, and 3 of those side by side and next to.
Or just a telnet attempt against that port. Telnet attempt.
Okay, and then to put it in a sort of script.
Yeah, but the ping can be vanished.
Okay.
I had one comment. One of the best little security things you can do is change your user from admin to anything not admin.
Exactly, that's a good point, because if we have admin, we are giving 50% of the information to the attacker. So if we change the username, but also you have to, now in RouterOS, we cannot modify the admin after we add a new user. So we have to add a new user and then remove the admin. Because if we add the new one and forget the admin, it happens sometimes.
Also make sure when you first set it up, it's not connected to the internet.
Exactly. Yeah, see because in less than 5 minutes you're going to be attacked for someone. Okay.
I know you're a software developer for MikroTik. Just one little question for the system resource profile. I know that, let's say an attacker attacks your router device and it's up 100% on CPU, and it mentions out what's using that full-on CPU. Now, these, it's like management CPU world. It's very generalized, and there's not really much resource finding out what exactly is the specific cause behind that. Are you going to ever implement a much more specific feature of where exactly the attacks come from, or what's using up the entirety of that CPU usage?
Actually, we have, for example, the profile where we can have categories about the use of CPU. And also, if you can use the torch to see all the connections.
It's like device specific, not so much more like feature, function specific. You know what I mean?
Personally, I haven't, by myself, I haven't developed any software to analyze that, but MikroTik have the application programming interface available, so we can go with develop something and get very customized information.
I was just going to mention package sniffer and Wireshark. That's pretty much all you need.
Yeah, for example, the Wireshark is a tool that you can analyze, but maybe you want something like a dashboard with showing all the. In that case, there are some in the market, but maybe you will have to customize some. things there.
Question regarding the raw part of the firewall. When you bypass the connection tracking that way, do you still have your packet counters available?
Okay, when we are using the pass, the fast track, usually we are going to do this with we are going to filter the new connections, and then we can fast track the related connections, all the traffic that is coming through the established connections. In that case, the firewall filters, queues are not going to be, these packets are not going to go through all these instances.
So usually we go for simple solutions, logging the IPs and banning them. Under what situations or what kind of attacks do you target the incoming connection?
Okay, there are hundreds of different attacks. Even in each protocol, we can have a lot of threats, but in this specific case, we are covering the ones that we have just seen. And in this case, we are using the drop action. In some cases, we can go with TARP to keep the connection alive and just don't allow it. Maybe after we can limit the number of connections and get some kind of better performance of the device. But personally, for this type of attacks, I prefer the raw and drop for the UDP that usually are the most, the attacks that have more effect on the devices.
If you're using the raw table to filter out what you don't want to come into the table, then, or into the firewall, then you won't be able to separate, you wouldn't be able to make a list of addresses to block. Is that correct?
I didn't get your question.
If you use the raw table to filter out certain protocols or data, then you wouldn't be able to add any of those addresses that are incoming trying to establish the connection into a list because it never makes it to the firewall.
Okay, actually the Roadtable is under the firewall, but this is analyzed before the connection tracking. We can now filter using specific features of the TCP states, for example, because this is coming before the connection tracking. But we can use it very useful, for example, for the UDP flow because we are dropping a specific traffic and we are not allowing that this traffic gets in the connection tracking. So after that, we can manage all the rest of connection in filter. So the raw is kind of a complement for filter, just for a specific traffic that we want to target, but that don't mean that we are just going to use the raw section. It's just like a complement for a specific traffic.